Even before we continue to the next topic, let us do a quick recap on what we have discussed until now. I'm using a tool called FreeMind, which is free for download. I will also be uploading this mind map onto the tutorial. We have started off discussing about the data types. We predominantly have two data types, which is continuous and discrete. If we can represent something in decimal format, and if it makes sense, that is continuous data. If we represent something in decimal format and if it does not make sense, for example, number of laptops, I can say I have one laptop, or I can say I have two laptops. I cannot say I have 1.5 laptops, right? It does not make sense. Such data would be classified as discrete data. In addition to that, we have also discussed about nominal data, which is merely labels. For example, if I say Coke and Pepsi, I'm just giving the names, right? And then we have discussed about ordinal data. As the name itself implies, order, ordinal, order matters, right? So the direction of preference is provided. For example, if you say you prefer Coke over Pepsi, that means you like Coke more than Pepsi, right? That order is captured in ordinal data. And then we have discussed about interval data. Interval data would also capture the magnitude of the preference. Probably on a scale of 1 to 10, you would give a rating of 7 to Coke as opposed to giving 4 to Pepsi. That's interval data. But if we both give or rate Coke 7 each, does not mean we both like Coke equally well. Hence, we have another data which is called as ratio data. If you have ratio data, you can perform all statistical analysis with ease. So this is what we have briefly discussed about. And for ratio, you can think about the amount that you spend to purchase Coke or amount that you spend to purchase Pepsi, right? That amount will remain the same anywhere on the planet. So these are the data types that we have discussed, post which we have discussed about random variable. Random variable has two components. One is random, another is variable. Variable means any event that can take multiple values. For example, if you flip a coin, you can either get a head or a tail. If you roll a die, you can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. If the event or the output varies, it is called as variable. And if this event has chance or probability associated with it, it is called as random. And if you combine these two terms, it is called as random variable. And random variables are always represented using capital letter, and the values which random variable can take would be represented using small letters. Post this, we have also discussed about probability. Probability is given using this formula, which is interested events divided by total number of events. And using this particular formula, we have calculated a lot of problems. This is the most important part, probability distribution. Most people get confused here. If we can represent random variables on x-axis and probabilities on y-axis, it would be called as probability distribution. And we have continuous probability distribution and discrete probability distribution. If the random variable of interest is continuous, you call it as continuous probability distribution. And if the random variable is discrete, we call it as discrete probability distribution. So that's in short about what we have discussed until now. Let us proceed further. and discuss more. So we have discussed about probability distribution. Now let us discuss about a few applications of probability. Who doesn't know this actress? Yeah, most of you all might be aware of this famous celebrity whose name is Angelina Jolie. She has undergone double breast mastectomy when your statisticians have predicted that she would encounter breast cancer. Let me show you that article which was published on BBC. Look at this. Hollywood actress Angelina Jolie has undergone a double breast mastectomy to reduce the chances of getting breast cancer. And she has done that because doctors have estimated that she had an 87% risk of breast cancer. And when she has supposedly undergone this treatment, there were absolutely no traces of cancer cells, right? There were absolutely no, there was absolutely no evidence of malignant tumor. Still she has undergone, thanks to probability. Let me show you another example. Nowadays, if the judges are dealing with high-profile cases, they're expected not just to base their decisions on the evidence produced, but they also have to back their statements based on statistics. Let me show you one such example. Let me click on this. In Holland, there was a nurse by name, see, look at this, this is all probability, right? In Holland, there is a nurse by name Lucia de Burke. She was arrested in 2001 after the death of a baby under her supervision. Later on, when the investigations went on, people have found that under her supervision, 13 other patients died, roughly. And then she was sentenced to life in prison. But statisticians have come up to her rescue. They have done some analysis and they've found that the odds were 342 million to 1, that it is a coincidence. And based on this, she was released from the court. This is the power of probability. This is the power of basic statistics that you're learning now.